Kia ora, Year 12. This is question 1 from the 2018 probability exam. It's all about the normal distribution, and I'm going to try and get through all 5 parts of it in 15 minutes. So I'm going to do this using the tables. I know that lots of you will be doing it using your graphics calculators, and that's fine. You just have to make sure that you're still drawing a picture and putting in some working for what you're doing if you want to get above achieved in any question. So in this question, there are 5 parts, and the first 2 are achieved questions, and then this next one here is a merit question, and then we're on to 2 quite nice excellence questions, and it's all about temperatures. So just quickly reading through, every day temperatures are recorded around New Zealand, and NIWA gets the daily temperature by getting the average of all of those temperatures in one day at that place. Okay. Over the last 7 years, the daily temperatures in Reefton have been found to be approximately normally distributed, with a mean of 11.6 degrees Celsius and standard deviation of 4.8 degrees Celsius. So straight away we should be thinking about a picture that looks like this, with the mean at 11.6 and a sigma of 4.8. And we're going to use that approximation to do the first 4 parts. And it just goes over here. Correct answers alone are generally going to limit you to getting just achieved marks. So first, find the probability that a randomly chosen day in Reefton would have a daily temperature between these 2 values. That's the first question. And then the second one is to find the probability that a randomly chosen day would have a daily temperature over 17 degrees. So looking at those, let's first of all draw a picture of what we're after. So we want to know the probability that the temperature is between 11.6 and 18.8. So we'll call the temperature X. We're going to convert that now into a Z value, right? So we're looking for this area here between 11.6 and 18.8. Very conveniently, that lower limit is exactly the mean. So when I turn this into Z values, we know that that 11.6 will be 0, and we have to work out what the Z value is for 18.8. So remember, the Z value tells us how many standard deviations above the mean we are. So here, 18.8 minus 11.6 divided by 4.8 is 1.5. Okay, so intuitively, when we're up at 18.8 degrees, that's 1.5 standard deviations above the mean. And this is set up in exactly the right way for my tables. So the probability that Z is between 0 and 1.5 is what we have to go and look up in the table. So let's go, hopefully this is the normal table. Yep, here it is. Still got some marks on it from a few weeks ago. So the number we're looking for, the Z value we're looking for here is 1.5. So here it is here. So that's 0.4332. So that's my final answer for that one. Now you could, of course, do that on your graphics calculator, but if you did that, I'd want to be seeing at least this working here, okay? And then just an answer of 0.4332. And this is only an achieved question. So if you do go straight to the answer, I guess that's fine, but it's not very satisfying. Right, let's go on to the next one quickly. Where's it gone? Okay, so now we have to find the probability that on a randomly chosen day, the temperature is over 17 degrees. So very, very similar, slightly harder. We've got the probability that X is greater than 17. So here's my picture. Oh, very bad picture. There's 17. So we have to turn 17 into a Z value. So 17 take away 11.6 divided by 4.8. So that works out to be 1.125. So 17 degrees is 1.125 standard deviations above the mean. So the probability that Z is greater than 1.125 is this area on the curve here. So to find that, what we've got to do is to use if we're using the table, it's going to be 0.5 take away whatever this probability is. Okay, so I'm assuming if you're watching this video that you've done all the work using the earlier videos on the normal distribution, right? Otherwise, this won't be making that much sense. So let's see what we want. Well, the Z value that we're working with is 1.125. So here it is here, 1.12. And then the 5 is the little add-on bit out here. So we've got 0.3686, and we need to add on 10 little points to the end, so it's 0.3696. And that gives me a probability of 0.1304. And as I said before, this is just an achieved question, but you're not going to know that when you're sitting in the exam. You can do all of that directly on your graphics calculator. But the working that I'd like to see is this, a picture like this, and then this, if you're doing it with the table. Of course, if you're doing it with the graphics calculator, you're not going to have that line there. You'll go straight to this answer. Okay, on to the next question. Let's see, where's it gone? Okay, part 3, the yellow one. People in Reefton talk about the hottest 1% of the days as being scorchers. What is the lowest possible daily temperature for a scorcher day? So this is an inverse normal problem where we're looking to work backwards. So we're given a probability distribution, and we're going to get rid of that triangle and turn off the lovely ink to shape feature in my OneNote. So this is what we're looking for. What is that number there that cuts off 1%? And we want my answer to be about a temperature. But we're first going to work this with a Z value. So we're saying what Z value will cut off 1% there. So that means that what I'm looking for is the Z value that's going to give me 0.49 here. So looking back into my table, we want to look through all of this bit to find the probability, which is 0.49. So let's look down here. Where are we? 0.49. Here we are. It's around here. So it's going to be 2.32. 2.326 is the Z value that I'm after. So the probability that Z is greater than 2.326 is what I want, because that gives me 1% in this upper tail. So the Z value is just how many standard deviations above the mean I am. So we're solving this equation. So x is equal to 4.8 times 2.326 plus 11.6, which gives me 22.7648 degrees Celsius, which is a pretty stupid way to answer a temperature question. So I would then write it in context. The lowest scorcher temp is approximately 22.8 degrees Celsius. So that just sounds crazily low. I wonder if this data is for real. I know Reefton is kind of cold, but I didn't know it was that cold. Okay, so there we go. That's the first 3 done. So I've got 6 minutes left to try and get through 2 excellence questions. I think that's going to be pushing it, but I'll give it a go. All right, so we're still working with Reefton and normal distributions for this next one. And then for the very last one, we're just working for any normal distribution. So using this normal distribution, we're told that the probability of a daily temperature below 9 degrees is 29.4%. Now let's suppose that the temperature's increased due to climate change, but the standard deviation has remained the same. So that means the standard deviation is still going to be 4.8. What would the mean daily temperature for Reefton need to become to make this probability, this one here, fall to 20%? So let's draw a couple of pictures of what we've got. At the moment, the probability that the temperature is below 9 degrees in Reefton is a whopping 29.4%. And that's with a mean of 11.6. Now, if that whole curve shifts along and temperatures go up, then the probability of it being cold is going to get lower. So what we're being asked to find is this. What will the mean have to be if the probability of being below 9 is only 0.2 or 20%? So like every normal distribution problem, this collapses down into finding a z value. At the moment, we know that 29.4% of the time, the temperature is below 9. So we can go and figure out what z value matches up to that. So we're going to draw the z picture. I'm going quite slowly now. Here's my z value. What z value is going to cut off 0.294 here? Now when we look up in our z table, or we can do this on our calculator, we're looking for this area in here. Actually, we don't have to do all this. Okay, forget this. This is way more work than we need to do. All we need to do is to find the z value that gives me 0.2 in here. Okay, so we don't need to go and work out any z value for that, right? But we just need to figure out what z value will cut off 20% here. And if we've got 0.2 there, we must have 0.3 in here. So again, we're going to go hunting in our normal distribution table. Right, we want 20% in that bottom tail. So if I want 20% there, that means I want 30% here. Using the symmetry of the graph, that means I'm looking for 30% or 0.3 here. So I'm going looking in here to find 0.3. And here it comes. So it's at 0.841. So z equals 0.841, maybe 0.42. I think I've said 0.841 when I did this. Yeah, you can't get it exactly on there, right? But it's closer to 1 than 2. But remember, we're looking on this side of the mean. So my z value is going to be a negative number. It's going to be negative 0.841. So what we're saying is that the mean daily temperature has to be 8.841 standard deviations lower than the mean. So we'll draw the z picture first. If we are 0.841 standard deviations below the mean, then there's going to be 20% chopped off in here. And we want that to be at 9 degrees. So what we have to solve is this. We're going back from the z value to the x value. So we get negative 0.841 is equal to 9 minus mu divided by 4.8. So we don't know this mu number now, but we know it's gone up. So hopefully our answer is going to give us a number higher than the 11.6 before. So just multiplying both sides through gives us this. Now I'm going to subtract 9 from both sides. So we get negative 0.841 times 4.8 minus 9 is equal to negative mu. That gives me negative 13.030368 is negative mu. So mu is equal to 13.0368. So the new mean must be 13.0 degrees to 1 dp. Okay, 15 seconds left. Thanks very much for watching. Hopefully that made sense. I'll do a separate video on the 5th part of the question.